Hey, good afternoon, everyone. My name is Jason. I'm Microsoft. I work on the core networking team there, and joining me today is Manasi.
I'm Manasi Deval. I work at Intel, and this is a joint project that we worked on together. And go ahead.
Do you have the clicker? Yeah, legal notices. Okay, agenda. So why do people want fast network processing? Well, we're going to talk about some motivations for why we're doing this, why we're bringing DPDK to Windows. And we'll talk about that journey, what it actually entailed, the architecture that we went after. Also, some of you may have heard of a technology that Microsoft had called Packet Direct. It has since evolved, and so I kind of want to give you guys an update on where that evolution has led. Then we'll do roadmap and Q&A. So for the first part of this talk, just to set some context and motivation, there's a lot of applications out there and real-world scenarios where milliseconds, microseconds even matter. And so whether this is an Olympic swimming race or whether it's doing high-frequency trading or even in gaming competitions, it's really critical to ensure that you have the highest bandwidth, the lowest latency possible for all of these different real-world scenarios, but also for a development perspective for computer applications. So Windows really needs a high-performance data plane that can be used by user mode applications doing video, streaming, or gaming. We're also interested in looking at some cloud infrastructure that we can perhaps take advantage of DPDK and accelerate that data path as well. But the area is really rich, everything from IoT gateways to network intrusion detection systems and even perhaps some NFV type appliances. There's a lot of interest in actually having a high performance data plane on Windows. And so we've evolved our data plane over the years, obviously. And the history goes back, even for native hosts before we had virtualization, where we were doing a lot of different technologies like RSS spreading, so on and so forth. But that's evolved as we've gotten more into this virtualized space, adding new and additional offloads, both software focused and then hardware offloads like VMQ, VMMQ. We're continuing to evolve that story where it's not just accelerating the host network itself or stopping at the host layer, the VM switch, but also accelerating into the guests also. So using technologies like SRILV, we're able to bypass the host operating system. Now this technology in Windows has been around for a while, and what you'll see in the future basically is more and better support for multi-tenancy requirements that go along with having a guest VF driver actually in a VM or in a container in the future. The other part of that story is the user mode applications themselves. And so it's not enough just to accelerate the host or the guest VMs or containers, but also the applications need acceleration. So we have technologies today that have been around for a while that use basically our WinSock APIs, which it's a socket library that Windows supports, doing something called Rio sockets to pre-allocate buffer regions and to get a little bit more maximum efficiency and capacity out of those applications that require high throughput. That didn't really go far enough, though. Some of the evidence we've seen, the Rio kind of taps out at about 750,000 packets per second in some of our internal testing. And so because of this, we're wanting to bring DPDK to Windows. So I'll turn it over to Manasi at this point.
So when we started the project to port DPDK to Windows, we had a couple of goals in mind. The first one was that we match what is there in open source, just have parity to start with. And the next step is to come up with more innovative features. So, when we go from one OS to another, there are certain OS-based restrictions, certain development restrictions. And we wanted to first gain parity and then move over to having, doing some innovation in that space. Today, we are only presenting what we did to gain parity. So to start with, our aim was to make DPDK look exactly like open source and also do all the same features. And at the point of this saying that we are done, we should not have to say that, oh, we don't have this particular feature. Everything should be in that. To start with, The first problem that we ran into was that we didn't have a UIO kind of a driver available on Windows natively. So we did some work to write the UIO driver, thereby exposing the NIC or the network device into user space. And then we went over, the user space applications, DPDK libraries, and the Kemel-Mode driver, and worked on porting the complete set to Windows. So we had to do some work to get the ICC compiler going, get some performance-based changes into that for the ICC compiler. And then the last bit that we had to do was to make these changes in a way that they are maintainable and and clean for other people to adopt and use. So as you can see in this architecture diagram that I have on the slide, we basically made several changes into the Kemel-Mode driver, the UIO driver, and how the DPDK subsystem will talk to the UIO driver. Over here, I have some more details on the exact changes that we made. So what we tried to do here was to keep the top and the bottom layer exactly the same. The bottom layer is the Kemel-Mode driver, that's IHV specific, and we wanted that to not change to the extent possible. The DPDK applications, if we can keep them static, they don't change, then they can be ported to Windows DPDK very easily. But that means that the DPDK subsystem would have to be created to be OS independent in a way. And there's been a push in the DPDK world already to be able to keep OS specific libraries in specific files. So the RTE set of files is what we modified and made it Windows specific. Now, several of these were easy changes, but then we ran into some difficult changes, and we wanted to make them without sprinkling if-def windows all over the code. And some of the problems that we had were with GCC specific implementations that were available for open source, but we could not use them as is on Windows. So porting things like type-of or attribute constructors were challenges that we had to overcome in order to have the DPDK running. But that said, we got through all that, and here I have a demo. So what I'm showing here is a 2-port device. This is the devices we are showing here are the Intel 710, which is a 2-port 40 gig card. So we have 2 of these cards, and I'm generating traffic using packetgen. So that's a standard packet generator, nothing new there. The packets are being received by one port and transmitted out by another port using the application L3 forward. That's also a common DPDK application. So you can see here, right side is the Windows machine, left side is the packet generator. And you can see that we are running L3 forward on the right side. And then on the left side, we are running packet generator. Now, when the demo starts, this is a video recording of the demo. So we have the packet generating traffic to L3 forward and L3 forward sending it back. So there's not a lot of spew on the demo, it's on L3 forward itself. But we need to look at the packetgen, which will send and receive packets. And you can see it's sending at line rate and then receiving at line rate too. So it's just about starting up now. And you can see the packets per second have gone up. You can see that a total of 71.4 million packets in each direction. Okay. And this is just some more information about the systems we used for the demo. But you can effectively see that the performance that we are getting with Windows is at par with what we were seeing on Linux. And back to you, Jason.
Okay, thanks. Yeah, so we're really excited about these results and the partnership we've had with Intel to bring DPDK support for Windows. We went from a technology like Rio sockets that didn't even make it up to 1 million packets per second to DPDK now running at over 70 million. So we're really excited about that. We have code. We have a UIO driver code that Manasi mentioned, as well as patches for the DPDK version 17.08. I was really hoping that I push a button and say, okay, it's published now, you guys can go download it if anybody's interested in running it. Unfortunately, that's our legal team, both Intel and Microsoft legal team, that's still figuring out the details there about how, making sure it's okay to release this. So there's no red flags, it's just a process. Hope to have an announcement soon, at which time we will be mainlining these changes up into the Git repository. So again, applications and use cases, as we've been doing this joint development, and we've been talking with other teams internal to Microsoft, and do have some promising scenarios and prototype discussions that are underway. I'm not going to say too much detail about them at this time. Hopefully in a year you'll have us back and we'll be able to discuss more about what we were actually able to accomplish. But we are doing things with network security and just running some infrastructure workloads, prototyping with DPDK on Windows now. There's additional classes of applications, I think, that would be of interest to run, that would take advantage of DPDK on Windows. Certain applications themselves don't really require a full TCP/IP stack. Anything doing forwarding or a lot of the NFV appliances don't really require that. There's also newer applications, potentially microservice, that will bring their own custom protocol stack into user space itself. And so those are the ones we're really wanting to capitalize on. A note about kernel mode. So up to this point, we've been speaking primarily about user mode and accelerations there. We did have this technology, again, I mentioned before, Packet Direct, which was very similar architecturally to DPDK in that it had a polling model, basically. So instead of being interrupt driven like the Windows NDIS stack is today, using these things called net buffer lists, it's actually polling the hardware to see if packets are available for processing. This was an experimental feature that was released in Windows Server 2016, a year or so ago, and it really accelerated just the VM switch. Now, we had thoughts about how do we actually push that up into higher levels, into the guests themselves, and even into user mode. But we had a lot of learnings around Packet Direct itself during that bring-up time around extensibility and feature gaps. So we really wanted to focus on kind of two different threads. One, we wanted to join the industry more on what the industry was going after as far as user mode accelerations. And so we wanted to go with DPDK, obviously, for those reasons. We are also looking at accelerating our kernel-mediated I/O path, specifically for some new consumer devices that are coming out. You're going to see some more talk about this. It's in the very early stages. But again, it's going to be an evolution from Packet Direct that basically uses a new driver model as well. Windows drivers are written to a specification called NDIS, which has been around for 20 plus years. And so we're wanting to take a lot of the things from NDIS that are siloed at the moment and allow driver developers to actually target those things in a more generic way. The people who are used to this thing called the Windows device or driver framework know how to program too. So instead of NDIS doing all the things around power management, DMA, there's driver frameworks that do that for us, so it will be more generic in that sense. We'll also be bringing up this new network data path, as I mentioned, with the WinSock network socket libraries sitting on top of that. So more details on that later on. This is the obligatory Microsoft now loves open source software slide. Hopefully you guys you are seeing more and more contributions from Microsoft in these Linux Foundation projects and others in the open source community. One of our employees is like the #2 contributor, I think, right now to the Docker code base, John Howard, so that's really cool. We're also doing a lot of work with Kubernetes, and then Linux, obviously, as well as a point of integration that we're working on and adding DPDK to this list. So hopefully next year when John shows his slide about OS adoption, you'll see Windows up there as well. So again, working with Intel closely to bring this, wanting to develop really a high-performance ecosystem around Windows applications, and would love to hear from you guys if you have any use cases that you're interested in exploring with us. A little bit about our roadmap going forward. So right now, this really is targeting just Windows native hosts. And so with some of the use cases internal at Microsoft, that's fine for them, and we're going to work through those native host appliances and applications to use DPDK. We also obviously started with Intel and are happy with that partnership, but we want to extend it out so that other IHVs, Mellanox, Sheltio, QLogic, so on so forth, can bring their pull mode drivers to Windows as well. Since we made this generic UIO driver that has the same northbound API surface as Linux, it should be an easy lift to actually bring that PMD that you have on Linux to Windows, because it's going to target the same API set on the UIO path. After that, I think we are going to mainline this code, make sure it compiles upstream, work with any partner labs that are being brought up, like at the, I think it was University of New Hampshire, where a partner lab is being stood up to make sure that we maintain parity, maintain functional and performance parity with Linux. We're also wanting to then go into the guests and also coexist with possibly some other management stacks. Right now there's a huge emphasis on DPDK, as some of these talks have already talked about, kind of takes over the whole system. And so how do we do better processing, better security management, better isolation to handle multiple applications with DPDK? So we have some ideas there. Longer term, we are looking at protocol stacks, user mode protocol stacks. I'd say that's definitely further out, but we'd be interested to talk to you guys. I've already talked to some people here in the audience, so looking forward to those conversations as well. And then again, just security and better hardware support for spreading is on our roadmap. So with that, I'll end to see if there's any questions from the audience.
Got one over here.
Hi. I don't know what you mean by UIO driver. For me, UIO is a Linux-specific kernel driver. I guess you mimic the same in Windows. And if it's a kernel driver, why not push it in Windows?
So it is the equivalent of the Linux UIO driver. And in that sense, we can consider where it should live. That's a more long-term decision. So currently, in terms of development, it does the equivalent of the Linux UIO driver. So it's a kernel mode component that exposes the PCIe device into user space.
So right now it's targeting all public Windows APIs. There's no special sauce in that UIO driver. It's just a kernel mode driver right now. And so the idea is, like Manasi said, we had to have some way to expose that memory region into user space. And so we brought that Linux concept of UIO to Windows.
Okay. The experience shows that having a 8GB UIO driver in DPDK was a huge mistake, at least for maintenance purpose. So the policy now is to reject any kernel driver in DPDK.
Okay, that's a good challenge for us to keep in mind when we come to upstreaming this.
Yeah, so we have to discuss about it, but if you can push it in Windows, that's really better.
Okay.
You know, DPDK is not a kernel project. It's just about user space. I guess I missed
the comment or question. Are you saying it's better to ship that UIO driver like inbox as part of Windows rather than distributed externally?
Exactly.
Yes, inbox.
Okay. Well, I'd be interested to hear more about that offline and talking to you about that.
And second question, you are saying you need to add some support in every PMD for your system. But until now, the PMD can work on Linux and FreeBSD. They are just relying on mempool, mbuf, and other libraries. Why? Is there something specific to Windows?
So, like if we look at the slide here, there are some constructs here that are not fully covered by the compilers that we have on Windows. So, if I had the GCC equivalent, extensions, then yes, there would be no change required. But since that's not there, in order to port the code right now, we need to make some changes. Does that make sense?
I don't know, I'm not an expert on Windows, but I guess you have some GCC on Windows. It doesn't work.
The what on Windows?
GCC compiler.
GCC.
To a
What's
certain extent, I mean, we're using Intel compiler mainly for optimizations and for some of these workarounds. And so we're actually working with our internal compiler team at Microsoft that will be able to spit out this code. That's something that we're also working on in the future. But yeah, I mean, going back to your Kemel-Mode driver point, I think the idea is it should be largely the same across the board from whatever IHV coming from Linux or BSD to Windows. The only Windows-specific implementation is hidden in that UIO driver. And so that's the, where we have the different RTE libraries that are on the page and the buffers, so on and so forth. But the abstract, the concepts themselves, the APIs should be the same going northbound into the user space.
Okay, thanks.
Quick question. I'm just wondering, are you planning on basically keeping the same build system that Bruce, for example, talked about? That's one question. The second question is Microsoft actually going to be taking on the test role of performance testing of all of the different capabilities as new releases come out of the DPDK? Or is the plan to roll that back into what we're doing within the Linux Foundation for testing?
I mean, just like we have these CI/CD workflows, processes being stood up, we've done this for Docker already, basically, where Docker was a Linux-only project. And so we really, made sure that there was Windows build systems available or did some sort of cross-compilation. And then to make sure that, whatever patches and codes, PRs that are being submitted are tested equally on Windows and Linux. So that's the Docker model, and we're doing that with Kubernetes as well. We'd love to see that happen with DPDK also for the lab that Bruce was talking about earlier.
Okay, that's what I kind of figured, and that's why I'm asking the question, because we'll have to take that into consideration, how we're going to deal with some of that.
Yeah, I know that added some complexity to you, but yes, that is the direction we'd like to go.
All right, great. Thanks very much. Good, very interesting.